Hey guys, Mrs. Horn here. We're going to kick off the biochemistry unit with some homework tonight, focusing on bonding and shapes of molecules. Before we get started, I'd like you to define these three terms by using your textbook. We'll follow the same procedure as always, and I want you to define them in 5 to 10 words. So there are three types of bonds we're going to talk about today. One is covalent bonding. A covalent bond is when there's a sharing of a pair of electrons between two atoms. A good example is a pair of hydrogen atoms. So I've made a little sketch over here, which I would also like you to do on page 5 in your biochemistry packet. I've got two lone hydrogen atoms, and each hydrogen atom has carries one electron. However, it has the capacity to hold two. So when those two hydrogen atoms come close together, their shells actually overlap and they are sharing an electron. When talking about covalent bonds, it's important to understand the difference between a polar covalent bond and a nonpolar. Nonpolar bond is a bond that's between electrons that are shared equally. This that I've drawn here is an example of a nonpolar bond. Also a bond between two oxygen molecules. The double bond between two oxygen molecules would be considered nonpolar. They're shared equally, meaning they're pulling on each other with the same force. A polar bond, this is when electrons that are not shared equally. Water would be a really good example. So the oxygen and the two hydrogens, it's not an equal balance of charge, so that would make it a polar bond. An ionic bond, this is a bond that's formed based on the attraction of the opposite charges. And salt is a really good example. Sodium chloride. Sodium is a positively charged atom and chloride is a negatively charged atom. And the third type of bond is a hydrogen bond. This is a bond that forms between hydrogen and an electronegative atom. I've got a picture over here of a bond formed between the hydrogen from a water molecule and the nitrogen of an ammonia molecule. The pink represents the hydrogen bond. Out of everything that's on this entire page, the most important thing is what I've highlighted in yellow. And what we need to know is that the shape of a molecule is very important to its function in a living thing. Molecules, based on their shape, determine what they can do in an organism or what they can do in your body. Their shape determines their function. This will come in handy later in the unit when we talk about the shape of proteins, the shapes of enzymes. Later down the road, we'll talk about shapes of receptors. Their function is all determined by what they look like and what their shape is. In a real-life example of this, there are specific drugs, could be over-the-counter drugs, could be not over-the-counter drugs, that have a specific shape that can bind to different receptors in the brain and help relieve pain, relieve stress. Morphine is an example of something that can get rid of pain because it's connecting to a pain receptor in your brain so that your brain is no longer sending messages of pain. It eliminates that feeling by connecting to those receptors in your brain. Now, if you were a pharmaceutical researcher and you wanted to learn about a shape of a naturally occurring substance in your body, why would you want to do that? Why would that be important? And it might come in handy so that drug companies could synthesize or make molecules that your body needs, but maybe your body produces them in low amounts, or maybe your body doesn't produce them at all, and you need those molecules. So maybe pharmaceutical companies would want to research the shape of molecules to understand how to make them for your body so that your body can function normally. So those are all the notes I have for chapter 2. But before we close out, I do want you to look at that blank page that you have over on page 4. That's our input page. And there are 2 things I'd like you to do. The first is I want you to create a chart that's going to encompass those 3 types of bonding that we just talked about. Give explanations of each of them, and then an example of each. And then the very last thing is a simple fill in the blank for me. The function of a molecule is determined by its what. Okay, these are the most important things that we got to pull out of today's notes. You can pause it here so you can write these things down, and I hope that helps.